Hi everyone, welcome to another Qt tutorial. So in this tutorial, we create a Qt development environment for Jetson Nano. There will be 4 parts. In the first part, we will create a virtual machine with Ubuntu. The second part will be about creating an SD card, image preparation, let's say with the default one, default image. Third part will be about Qt compilation in the virtual machine. The last one will be about QtCreator installation, device configuration, and running the simple first example. So let's start. I will use a VirtualBox to run a virtual machine. You can install from here. I use also the Windows as a host. You can also use a Linux. Also from the official website, you should install Ubuntu operating system freely from here. Then run a VirtualBox, create a new virtual machine, give it just a name, whatever you want. Choose Linux here and choose Ubuntu 64-bit. Click Next and give as a RAM as much as you can. 8 GB will be enough for me. Create a new one. And here 150 GB I just give for the file location for the memory. And give a path of the Ubuntu disk image file. Then choose. Just click Start. It will start to set up the Ubuntu image as a virtual machine, right? It will take some time, as you expect. I will cut some parts in this tutorial, so you can skip if you want. If you don't want to watch this installation, you can skip directly the part 2. Install Ubuntu, choose your language, find your keyboard here. It's a normal installation. And it will erase all the disk. That's the virtual disk actually, right? You can install simply. Give a name for your operating system as a user, right? So you can change if you want in the next. Jetson Nano Qt will be okay for me. Yes, you should restart the virtual machine after installation is completed. Just click Restart Now. If you not touch Enter here, it will wait. So just click Enter. If you install already Guest Edition, then will be no problem about the full screen thing. If you have some problem about the screen size of the virtual machine, so you should install the Guest Edition. You can Google it simply. Just skip. And as you see, there is some problem about the size. So let's restart the virtual machine. Also, this is important here. Enable the clipboard and give core number as much as you can also. It will make faster compilation for the Qt. Otherwise, you will wait more. Okay, I gave here 8, but it will not work for me because I have only 4 core in my host machine, so I can only give 4 number, right? Yeah, it is not working, interestingly. So let's install the guest edition here. Okay, run. Okay, ask for my password. I think after this, it will be going to the full screen, I think. Let's restart again. Yeah. We should install the guest edition. Okay. So first, we'll update the virtual machine. So it's updated, then upgrade your virtual machine. Click yes. It install some bunch of some packages, necessary packages also for the Qt compilation. Also, you have to install some build essential, GCC, and other packages that I will show you right now. Actually, as it's okay. This is the version here, as you see, 20.04. So restart. It will ask for restart. So restart your virtual machine again. So this is it for the first part. Let's go to the second part. SD card preparation for Jetson Nano using the default image, which is Ubuntu. You can download this Ubuntu from the this website. This is called a Jetpack. There are a lot of also tools for AI applications, but we will not interested in right now these things, right? Just install the Qt. You can click here, Jetpack 4.4.1. I use for Jetson Nano, not a 2 GB, this one, 4 GB. This is my board. Choose the correct one. This is around a few gigabytes, so it will also take some time, but also before I install it. So just unzip somewhere. This is the image, ST blob. I use a disk imager. Plug your SD card to your computer. Then write this image to your SD card. You can use also another tools. Write successful finally. Then take your SD card, plug in your Jetson Nano like this. When you first run, it will ask you to about some configurations. So after this, you will get something like a desktop. Okay, and open a new terminal. The first thing is giving a password for the root. We can have we can need this in the next. And also we have to enable this SSH connection. Open this configuration file, and here permit root login yes. It's same with the Raspberry Pi. But I didn't run as a sudo user, right? Let me check. Yes, I cannot write. This is the read on the file, so I have to run as a sudo. And this is still not changed, so sudo using vim etc sshd-config. It's in the etc/ssh file. Change this line like this. Permit root login yes. Let's check again with cat command, and it is here. Where is it? Yeah. Okay, it's cool. So now we will update and upgrade the operating system like what we did before in the virtual machine. It's the same actually, it's the same Ubuntu. Sudo apt update. And after upgrade, we will install some dependencies for sysroot file, like xrender, xidev, and other things. The important thing is the Mesa libraries for OpenGLAS. We will create our applications on top of the OpenGLAS. That means we will not use the X server. We will pass the X server, which is good for embedded devices actually. So we will not use any windowing technology here. So let's install some dependencies which are necessary for building the Qt, like as I told you, XCB. We will play with these things later, not in this video, but I will show you more what we can do with these things, like in WebGL, OpenGL, and other things. Let's first set up this development environment. Then libgls mesa dev, libgl1 mesa dev. Yeah, sudo again. These days are already installed, cool, but it's a good idea to check again. So let me show you where is an AGL, where is an related SO files. This is not, I think. As I remember, it should be Tegra AGL file, but let's try to search with an OpenGLAS. No, this is not. Let's go directly to file, I think. I couldn't remember. So USR lib. I think not a Tegra. Tegra AGL should be, I think. So one back. Tegra AGL, yes. This libgl es v2 should be exist here. Otherwise, you have to check again your comments. We will give this path in the next for configuration Qt. This is important, this is necessary. So the second part is finished here. So reboot your device. Then let's start the third part, the Qt installation on a virtual machine. Open your virtual machine and be sure the target can be pingable like this. So now we install some packages, necessary packages like a build essential, GCC and other things. But it's a good idea to run as a root. So just type sudo bash and give your password and install gcc, git, python, the other necessary things. All the commands you can find on the internet. Actually, I will share these things, the history. You can find below the video. I think we didn't install the build essential, right? Yeah, make lib tank dev, clink dev, and build essential. Otherwise, without build essential, for example, you cannot compile the Qt. It will give an error. I also created a file, a directory actually, under the OPT also, but you can put somewhere wherever you want. It depends on you, right? People ask me generally why you are just creating it under the OPT, but there is no, rule here. OPT, I just Qt5 Nano, Jetson Nano, the name of this directory. And I will give an ownership for Jetson Nano Qt user for this file. Then now we will install the first step, Linaro toolchain we will install. I will try GCC Linaro 5.5.0, which is the old one actually, a few years ago. I tried with this and it was working. So you can try with another toolchain if you want. Okay, I trust this one. And from the Linaro org you can install. You can check other things also, other toolchains. Toolchains is the first thing, right, for the embedded devices. When you want to do something, to build something, create something, the toolchain you should have to handle the first thing. So click here with the wget command, copy the link and install here directly. After this, untar the file here, tar xf using. If you list under the bin file, bin directory, you will see the related binaries there. Let's install a Qt from the official website as a next step. I will install 5.15. You can try another version also. With the wget command also, we can install here simply. Just right click and copy the link. Then wget and paste your link, then it will install right. After installation, enter this file, xz file here, under the same directory, Qt5G Nano. Also, we have to export the path for, actually I forget. Let's list the tool chains here. These are the GCC and G++, as you see. We have to export here as a path for the compilations, right? This is necessary. Qt5G Nano, GCC Linaro, and as a bin file. Echo path, yeah, this one with the dollar sign. This is okay. So it's also a good idea to add this line in the bash RC. So we have to, if you reboot or if you restart the terminal, then it will be gone, right? So it's a good idea to add in the bash RC file. Then we synchronize the sysroot with the target lib and user include user lib. We have to create a sysroot directory in the virtual machine, right? When you want to build something, you need a sysroot. Also, it depends actually. Meaning of the sysroot can change, depends on the system, what you want to do actually. But here, we put the necessary packages in the sysroot. And we will give this path to the Qt in the next. So, with the rsync command, rsync command, first we synchronize the lib file with the sysroot file we create under this Qt5G Nano directory. There are three files, three directories: lib, usr include, and usr lib. On the target, I mean. As you see, the Tegra kernel drivers. Now let's ls the sysroot. I want to show the directory here, whatever. rsync mine is avz. Now usr include with the us sysroot usr. Okay, it's fast. So usr lib and sysroot. usr lib with sysroot. Sysroot usr. Okay. As a next step, we will install the sysroot relative links Python script, which handles the soft links. When you copy this soft links from your host machine, it will not change, right? So we have to fix these things, fix these relative links. Let's finish first. USR lib and sysroot USR, the last one. Probably you will wait more here. I will make it faster, the video, to not bother you. It's bother me. Whatever, I will maybe put some background music in the next for this kind of tutorials. I don't want to cut every parts here, but sometimes, you know, this can be helpful for the people who do not have much more information about these things. As you hear right now, the DRM, DRI, SO files, also these are important. After running the sysroot relative links Python script, we will check again for these three directories. Then we configure our Qt simply, creating Qt5 build directory, let's say, but you can give whatever you want the name. It doesn't necessarily right now. It is not important. The important thing is here the OpenGL AS2. We will not run any windowing system. So in the next we will run a simple example, and it will going up the first full screen actually. So you don't have to make or any change for the full screen. It will automatically run as a full screen because of the OpenGL AS. This is important, as I told you, for the embedded devices actually. But there is also limitations for this. For example, you cannot run two window, right? Actually, there is no window. That is why you cannot run more than one window. This is also the limitation. And what I see here, there is no configuration script for Jetson Nano. Also, we will create this one. Also, it will be cool. Okay, let's install sysroot Python. You can find on the internet. Here, I just click before, choose this link, then using the widget again. The root like this, tree like this, and let's make it executable. Then run this script, giving this sysroot directory, and let's resynchronize the three commands, the three directory again, lib, USR include, and USR lib, to see if there is some missing. It's okay. And USR include, sysroot USR. This is also okay. USR. This is also okay. Then go to Qt everywhere source directory. Then let's list first. These are directories, and in the Qt base make specs devices, there are configurations for the devices, for each device, example devices. But Jetson Nano is that exist here. we will copy one of this directory to update, to change. For example, take i1 g++, Qt-base, make specs, devices, Linux Jetson Nano. Just give a name. I will give just Linux Jetson Nano. You need a -r command, recursive, and open this qmake conf file here. We will change this file right now for the configuration. Okay, let's say Jetson Nano 4 GB. This is okay. This path should be changed. This should be arc64 and GNU. This should be USR include. This is the sysroot file, right? Also, this must be same. This should be same also. This row, I don't know, it should be first include directory AGL. We have to give the directory path for an AGL. This is sysroot. The path should be the Tigra SO files I just showed, right? It should be include. Tigra AGL here, let's check again. I couldn't remember. Yes, lib arc GNU Tigra AGL. Yeah, here. Yes, I said okay. What we checked before in the target, here we resynchronize these things, right? Now this file is in the also the virtual machine. This is okay. And this row options, hard float. This shouldn't be hard float. This will arc64, and v8 should be. This is not necessary. Let's remove. This should be crypto CRC, and this is not necessary also. AGLFS device integration, AGLFS key message in AGL device. Okay. Let's check again. User include arc64. Okay then. I will also share this file with you. Don't worry. You can find this file under below the video as a link. So create a Qt5 build directory and go into this directory. Then now you write the configuration. Configure OpenGLES2. The device will be Linux Jetson Nano, the name of the directory we just changed, right? This is device option cross compile. Qt5G Nano. I just give the path for the toolchains here. You can use tab button to go automatically. This should be like this, the GNU and one line. And as a sysroot, give the path uopt Qt5G Nano sysroot. As a prefix also, it should be in the USR local Qt5G Nano. Then open source, confirm license. I will skip the Qt script, Wayland, and also Qt Web Engine I will skip. Force debug info to see more info here. And also I will skip the Qt data visual 3D. I don't know actually what is it. And no make examples, it will be faster. pkk config. No use code linker -v verbose. Okay. Let's check again if there are some problems. Let me check, let me read. Local Qt5G and open source. I think it's okay. we can go with this. Yeah, after some time, if you don't choose the core number, it will take more time. We will get an error here. That is why actually I want to show you. This is the configuration. You have to check here. Okay, C++ standards. And OpenGLAS should be enabled. XML, these are just okay. Here, as you see, OpenGLAS are yes. That means they are enabled here. That is good. AGL on X11, these are also okay. AGLFS X11 1, 11 also it's enabled here. Okay, let's copy this one. Then I will share with you. You can also find this file below the video. It will help you to compare your configuration. Then make -G and give the number of cores. It's simply core number actually. So I just get an error here, which is related with GeoService or something like that for one of the Qt package, but I don't need this, so I will skip also this one. Okay, that is why it can help you. Maybe you cannot see this error, so you have to continue. Don't worry. Then I will skip Qt location package. I don't need it. If you see some error, something like this, you will have to search on the internet. Some of the package is missing probably in the sysroot file. So simply install on a target and resync again, then it will be solved. But for this Qt location, it is not necessary. I don't want to use it also. Now I think it's okay. Also we will see again the configuration data, what we see before exactly for OpenGLAS and X11 C++ version. So I will remove, I think, the directory. I will create again the Qt5 build directory to make it clean, right? Sometimes running this make again and again creates some problems that I don't want to deal with right now. Okay, let's check again the configuration. If you affect anything, the Qt location, I think it will not affect anything, but let's be sure. So copy this one. Okay. Let's, as I told you, let's remove, I think, but not let's remove. Okay. So I will get 4 here. I don't have 8 cores. Let's start again. Okay, if you see this is okay. If there is no error here, it means it's okay. So the next step, to make install. Of course, this, right, it was actually take much more, time, but I just cut the video here. I don't want to bother you. So after make install, we will have a QMake, which is a make file generator, like a CMake, right? This is the CMake for the Qt, which is called QMake actually. The idea is running the QMake for our binaries, our code base, to generate the binaries with compile way, let's say. Then also we will resync all the packages which is compiled right now as a crossly for our target device, Jetson Nano device. We will send this packages under the USR locale in the target, so it will automatically detect it when we try to run our applications, right? We will see it. That is, this will be all, I think, for virtual machine development creation, actually, development virtual machine creation for the Qt. Yeah, this is all. We don't see any error here. Good. Now let's check, let's list the QMake. It is exists or not under the sysroot USR local Qt5 Nano bin QMake. Let's check again here. These are the Qt modules, right? Qt multimedia, you know, WebSockets, Qt virtual keyboard, other things also. You can check more. Also in the Qt base also you can check these directories to learn more. Under the OPT Qt5 Geno sysroot USR local bin, there is an QMake here. This is the makefile generator, right? We will give this path in the next for the QtCreator to create our binaries for the makefile after the makefile generation, actually. So then rsync the files, the related files for target sysroot USR local Qt5 Nano to the in the root in the target USR local under the USR local. That will be all for this part. The next part will be about, as I told you, QtCreator installation and the first example. As you see, QMake also sent here. QML related files, other Qt related files, GUI related files also. XML web channel, virtual keyboard also. Let's run a virtual keyboard example for the first hello world example. Let's enable the virtual keyboard. It's also a cool module. It's also installed, actually. It's also compiled right now. So that's all. Let's go to last part. Then clear the screen and install QtCreator. It's around 900 megabytes. Some other packages also installed with this, because also QtCreator used Qt packages, binaries, dependencies actually. These steps are same with the video actually I shared in the YouTube before for Raspberry Pi. You can also watch this one. Then now we should export the XR30 actually, but it does not necessary actually. Right. Open a new terminal. I will run the QtCreator as a sudo, not a super user. Sudo QtCreator. It is different totally. So go to options. Now as you see, there is only desktop device here, kit here. We will create a new kit. So first we have to add the Qt version qmake simply. I showed you before, right? In the local here, in the bin, I think there is a qmake. It is okay, but don't worry about the red things right now. This is because the other things are not initialized. That is why just it's red. And create compilers. This is the tool chains we install for the Nano here. Choose the GCC for the GCC one. And this will be Linux 64 bits, okay. Apply and choose the G++. Give a name G++ G Nano and choose the GCC here for the G++. And so it's okay. Now, as you see, the red one is gone. Then let's add a device here. This is a generic Linux device. Give a name, give an IP address as a root. Don't worry about the public key, it will be failed. We will disable this key configuration. Now text it and it will be okay right now. Device has finished. Okay, go to kit again. Give a name to your kits. Just give some here G++ G Nano. Choose the compiler. Choose the qmake, Qt version. So don't worry about the debugger. I will not add debugger right now. Open a new file. Choose QtCreator application, empty application, the first example, let's say, in the home desktop somewhere. Okay, next. Use Qt virtual keyboard here. Choose this checkbox. This will enable the Qt virtual keyboard. We already compiled, right? So go next. So this is okay. Let's compile. In the main CPU, as there is not much thing. This is the Qt virtual keyboard line to call. Before send the data, send the binary, we have to add some system environment variables, which are this XR30 and the display variables simply. Let me check again. Yeah, this one, XR30. This is the Jetson Nano. Right side, you see. We should add run user 1000 GDM XR30. And first, let's give the display. This should be 0, like this. XR30, run user 1000 GDM and XR30. Run qmake, then makefile is generated, then choose release and build it. It's built right now. Crossly the binaries, our program is compiled crossly. So disable this C-length thing, C-length stuff. We have to reboot this QtCreator. You can reboot it. Now we can deploy the binary from here. I think it runs, I think, but it's a good idea to put something here. This is actually, it's not working actually, so we have to give the path for the targets here. Home, it's the target path, home G Nano desktop, where you want to put your binaries. Okay, let's deploy. Yeah, it is deployed, I think. Okay. You know, it's not deployed, so one slash is more. This one is more, yeah. Deploy again, run again, deploy again. I think, okay. Trying to kill, remote application killed. Okay. It is working right now, I think. So let's put some QDebug, some text in the main CPP, so we can see some output directly. Include QDebug. QDebug hello world, let's say, from Qt application. Let's compile and run again. Deploy here. And go to the application output, I think. Ah, this one is Nano. Sorry. Deploy again. Should I run? Yeah. Hello world from Qt application is running right now. AGFL, KMS, AGL device. Don't worry about these things. I will tell you later. Failed to load AGL device integration. In the target, right now it is running as a full screen. Right. And also let me share. Okay, let's first put here a text field to call at the keyboard. I forget to put text field here, so keyboard is not working right. Just there's an empty white screen, so this will be good for us. Let's compile again. We have to import the QtKeator controls, right? 2.12, okay. And run device. Stop again here and run again. Deploy, run again. Yeah, we are in this target right now, and there is a text field, right? When you click this, there are, as you see that there are two mouse pointer, right? One of them is for X server, one of them is an over OpenGL hard mouse pointer, hardware pointer actually. So one of them is working for our binaries, our binaries. The second one is working for the terminal, the other X server applications, right? But as you see that the other one is gone when you kill or change the screen from our binaries from program. So this one is an I took from my host machine. As you see that there are some dependencies to X11 here. This is one of the example binaries, doesn't matter. But our binaries has no dependency. You can check with an LLD command. So this is the point. This is directly the embedded device application. It will be faster and more robust. So guys, that is all for me here. I will share more videos about these things, Qt and other software stuff. Do not forget to subscribe, and see you again.